So one more time, I have total of 18 inches. I want to do isosceles. I want to make isosceles triangles. I want to make 4 of them. Like I want to give 4 possible solutions, 4 possible isosceles triangles. Each triangle has to be isosceles, as it's written in here. At the meantime, if I add the 3 sides, they should add up to 18 inches. All right? So I'm going to just check some numbers, see if it's going to work or not. Say I'm going to use 5 and 5. So right now I'm using how much from that 18? I'm using 10. So what's left? 8. So that's one possible combination of the 18. 5 plus 5 is 10, plus 8 is 18. Now I want to check, can I do a triangle using these measurements? What I mean by that is the sum of the 2 small sides is greater than the third side. Let's check. I'm going to take the 2 small sides, 5 plus 5. I'm going to compare that with the 8. If it's greater than 8, 5 plus 5. 5 plus 5. Is it greater than 8? The third side, because the inequality of the triangle says the sum of any 2 sides has to be greater than the third side. So 5 plus 5 is 10. Is 10 greater than 8? Yes. So that's one possible solution. So I can draw isosceles triangle, 5 inches, 5 inches, 8 inches. It's not drawn to scale because I know you're going to say the 5 looks greater than 8, but doesn't matter. As long as it satisfies the inequality of the triangle, I can construct it. Maybe the way I drew it is not accurate, but it could be done such way. Now I need to get another solution. I need 4 of these. So let's pick another number and check it. For example, can I do isosceles triangle? 3 plus 3, 6. So what's left from the 18 so far? Subtract 18 minus 6, 12. How can I check if these are going to work or not? I'm going to pick the 2 small numbers, 3 and 3. I'm going to add them and check, is it greater than the third side? Is it greater than the longest side? Is it greater than 12? 6 greater than 12? No. So this is not going to work. So you can't go smaller too much here. You need it to be greater than 12. But you can't make these too much. This is 12. I'm going to give you another example. Let's say I'm going to do 10 and 10. The 2 legs of the isosceles triangle, each one of them is 10. Can I do that? 10 plus 10, 20. I have only 18. How that's going to be done? Cannot be done. 10 plus 10, 20. I have only 18. So let's make something smaller. Instead of 10 and 10, let's try 9, 9. Let's check what the third side could be. 9 plus 9, 18. So I used the whole 18 just to make 2 sides. Nothing left to make the third side. So the third side is 0. Can I do that? Is 9. Let's pick the smallest 2 numbers. 0 and 9. 0 and 9 is 9. Is it greater than the other 9? No. But I don't need to do all this. If I'm doing 9 and 9 as 2 legs, nothing left for the third side. So I can't form a triangle. It's going to be something look like this. 9, another 9, and there is nothing left to make the third side. You're not going to be able to have a piece left to close the triangle. Like I can't put the 9 like this, 9 like this, then nothing is left to close this triangle. So far we have only one work solution. So let's try something reasonable. You see, when this number is big, it doesn't work. When it was 5, it did work. Let's try if it's 6, for example. The 2 legs, one of them 6. We know that the 2 equal sides, we call them legs. 6, comma 6. So now I have 12. The other one is 6. Can I call it isosceles when it's 6, 6, 6? Yes. As long as there are 2 congruent sides, then it's isosceles. Equilateral triangle is always an isosceles triangle, but isosceles triangle, sometimes it's equilateral triangle. Is 6, I'm going to take these two, 6 plus 6, is it greater than the third side? 12 greater than 6? Yes. So that's another solution. 6, 6. So that's another solution. So now that's second solution. This one also worked. So that's solution number 1. That's solution number 2. Let's try 7, 7. What the third side is going to be? 7 plus 7, 14. From 18, this is going to be only 4. Now I pick the smallest two sides. One of these two 7s and the 4. 7 plus 4, is it greater than the other side, which is 7? 7 plus 4 is 11. 11 greater than 7? Yes. So that's another solution. So that's solution number 1. That's solution number 2. That's solution number 3. We need one more. We need to find one more solution, and that's it. Let's try 8. 8 plus 8. 8 plus 8, 16. 16 from 18. 2 left. So 2 plus 8 is 10. 10 plus 8 is 18. So I'm using the whole 18. I pick the smallest two sides. 8 plus 10. Is it greater than the other side? Yes, 8 plus 10, of course, is greater than 8 by itself. So yes. So that's solution number 4. And we are done with this problem. If the length of two sides of a triangle are one of them 7, one of them 5, what is the range of the length of the third side? Like the third side could be from what length to what length. Remember, this time we are considering that third side by itself, and I want to find range of length for that side, like from what number it is going to work all the way up to what number is going to work. Before that is not going to work, after that is not going to work. So solution, now we need to concern about only one side. So the third side, I'm going to call it x. Let the third side be x. So this one side, the x, has to be less than the sum of the other two sides, 7 plus 5. And it has also to be greater than the difference between 7 and 5, 7 minus 5. So 7 minus 5 is 2. So 2 less than x, or x has to be greater than 2, less than 7 plus 5, 12. So what's the range of x? That's the range of x. Anything greater than 2 and less than 12, like 2.1, it's all right. If we're talking about whole numbers, I'm not going to say 2.1. I'm going to say if x at 3 is going to work, 4 is going to work, 5 is going to work, 6 and so on, 10 is going to work, 11, 12, no, it has to be less than 12. 13, no, it has to be less than